I will be working through the Chapter 6 Quadrilateral Review worksheet. Please feel free to pause, fast forward, as is useful for you. As we look at the first set of questions, find the value of each variable in the parallelograms below. So I see that there's expressions for the lengths of the parts of the diagonals. So I look at the parallelogram properties and I see that the diagonals in a parallelogram bisect each other. That means that the 3x plus 2 is equal to the 23 because they are congruent. It is bisected, split into two equal parts. So I can solve for x, subtract 2, divide by 3, so x equals 7. Then I do say the same thing with the other diagonal. These two parts of the diagonal are equal to each other because they were bisected. So I set the 7y minus 2 equal to the 5y plus 4. So to solve for y, subtract 5y, then add the 2, and divide by 2, giving me y equals 3. In the next parallelogram, there's a whole bunch of variables here. First thing I see is the letter A is a side length, and in a parallelogram, one of the properties is that the opposite sides are congruent to each other. So that means that A is equal to 12 because it's congruent to the opposite side, and B has to be equal to 7 because the opposite sides are equal. Then the other variables, angles, x, degrees, well, this is an angle measure, and one of the properties is that the opposite angles in a parallelogram are congruent. So x equals 112. Then I need to find y. Now I don't have the opposite angle for y, so one of the other properties states that consecutive angles are always supplementary. And so y plus 112 should equal 180. Subtract 112 and y equals 68. Right, the third parallelogram. Again, I have a side length here, this 8g minus 3, and one of the properties of a parallelogram is opposite sides are congruent. So the 8g minus 3 is equal to 25. Add the 3, divide by 8, and 28 divided by 8 is 3.5. Then the other variable here is f. And I see f plus 30 is an angle measure. I don't have the opposite angle, so I look for consecutive angles that are supplementary. So f plus 30 plus 72 needs to equal 180. Add the 30 plus 72, and then subtract 180 minus 102, and I get 78 for f. Okay, the next row, find the value of each variable in the rectangles below. So, in the rectangles, I see ln equals 4x minus 7. ln is a diagonal, and MO is the other diagonal. So I check, what do I know about the lengths of diagonals in a rectangle? Well, they are congruent to each other. So that means that the 4x minus 7 is equal to 2x plus 13. So I solve for x, subtract 2x, add the 7, so 2x equals 20, divide by 2, x equals 10. The next rectangle, 15x is an angle measure. It's got the degree symbol with it. So what do I know about the angles in a rectangle? Well, the definition of a rectangle is that it has 4 right angles. So if 15x is a right angle, that means 15x needs to equal 90 degrees. Divide by 15, x equals 6. Next rectangle, so I have side lengths, and the property of any parallelogram, including rectangles, is that the opposite sides are always equal to each other, or congruent. So that means that the a plus 6 is equal to the side across from it, 20. Subtract 6, a equals 14. To solve for b, 3b is congruent to its opposite side, 12. So 3b equals 12, divide by 3, b equals 4. The next row is finding the value of each variable in the rhombuses, or rhombi, below. So in this first rhombus, I see that I have an angle measure where the 2 diagonals intersect. Well, if I look at my properties of rhombuses, the diagonals in a rhombus are perpendicular to each other, meaning that they make a right angle. So if 9x is a right angle, that means 9x needs to equal 90 degrees. Divide by 9, x equals 10. Next rhombus, I see I have one diagonal and 2 parts of that angle are given here. So I look at my properties of rhombuses and see that the diagonals bisect each angle. So that means the 2x plus 39 and the 6x minus 9, those two are equal to each other. 2x plus 39 is congruent to, equal to, 6x minus 9. So as I solve for x, subtract 6x, subtract 39, and then divide by negative 4 to find that x equals 12. In the last rhombus, I see side lengths. Well, the part that we know about the side lengths of a rhombus is that all 4 sides are congruent to each other. That means 5x equals 15, equals 3y, equals 4x plus 3. So I choose whatever 2 are most convenient to work with. So if I take the 5x equal to 15, divide by 5, x equals 3. So just to check, 4 times 3 is 12, 12 plus 3 is 15, just like the other 2 sides. So 3y, that also has to equal 15. 3y equals 15, divide by 3, y equals 5. Right, now we move on to the trapezoids. Find the value of each variable in the trapezoids below. So this first trapezoid, I see the congruent markings on each side, which means that this is a mid-segment. It's connecting the midpoints of the 2 sides of the trapezoid. So the rule for mid-segment is that the length of the mid-segment, which is 15, is equal to the sum of the 2 bases. The first base is x plus 3, the second base is 4x plus 7, and the sum of those 2 bases is divided by 2 to find that mid-segment. So the opposite of of dividing by 2 is to multiply by 2. So therefore I have to multiply the 15 times 2 as well. So 2 times 15 is 30. The 2's on the right side cancel each other out, and so I combine like terms. X plus 4x is 5x, 3 plus 7 is 10. Now I get a much easier equation to solve. Subtract 10 from both sides, divide by 5, and we find x equals 4. So notice 4 plus 3 is 7. 4 times 4 is 16. 16 plus 7 is 23. 15 is 8 more than 7. 23 is 8 more than 15. 15 is exactly in the middle of 7 and 23. The next trapezoid gives us DF equals 4x, so that's the one diagonal. EG is the other diagonal, it's 2x plus 16, and I notice this is an isosceles trapezoid. Well, in an isosceles trapezoid, the property states that the diagonals will always be equal. So that means that these two diagonal lengths, 4x and 2x plus 16, are congruent. They're equal to each other. So I subtract 2x, divide by 2, x equals 8. And the last trapezoid, which again is marked as isosceles, in a trapezoid, the consecutive angles, so not the base angles, the non-base angles, are always supplementary. So 120 plus x needs to equal 180. Subtract 120, x equals 60. Well, in an isosceles trapezoid, one of the properties states that the base angles are congruent. So if we go along one of the bases, the two sides that are parallel, if x is 60, that means y is equal to 60 as well. And lastly, these find the value of each variable in the quadrilaterals below. So if we are given the 4 angles, or we're working with just the 4 angles of a quadrilateral, that means we need to set up an equation because the quadrilateral angles always add up to 360. So that means that x plus 106 plus 67 plus 131 needs to equal 360. 106 plus 67 is 173. 173 plus 131 is 308. So x plus 308 equals 360. Oops, I did not do my math correctly. So 106, break out the calculator, plus 67 plus 131 is 304. Didn't feel quite right, but I wasn't sure what my mistake was. Subtract 304 from 360, and we get 56 as the measure of angle x. Same idea for the next two. So if we have measurements for all but one of the angles, or we have this at one variable for those angles, set up the equation. So 80 plus 75 plus x plus 105 should equal 360. 80 plus 75 is 155. 155 plus 105 is 260. Subtract 260. X equals 100. This one does not have a degree symbol with it, which means I should put it in my answer. All of the other angles that we've had so far have all had degree symbols with them, but not on this one. And the last one, even though there's two angles we don't know, they both involve x, the same variable, so we can set up the equation. 110 plus 130 plus x minus 3 equals 360. So we have 110 plus 130 is 240. 240 minus 3 is 237. X plus x gives me 2x. So I subtract 237, and 2x equals 123. And so I divide 123 by 2, and x equals 61.5. There are degree symbols, so I don't need to put an extra degree there. Move my camera over so you can see 61.5. That's the end of the front side of the Chapter 6 Quadrilateral Review. For the back side, please go to the next video.